Okay, so this is section 1.6, which is modeling with equations. Okay, be sure you have your book open and you're looking at this. This is also basically, big picture is how to solve word problems. And that is really what it amounts to. Okay. So here are going to be our steps. These are sort of similar to what's in the book. I've just sort of worded them a little bit differently. Step number 1, figure out what it is you need to find. In other words, what is the problem asking you to solve for? This is usually in the last 2 sentences somewhere. Not always, but usually. All right, step 2. Translate sentences in the problem into algebraic expressions. That relate to the variable from step 1. Okay. Sometimes this takes a little bit of time to do. Step 3. Somewhere in this problem, is a fact or facts that will allow you to set up and solve equations. You just got to go looking for it. Think of it as a treasure hunt. I know you may not think the treasure is worth much, but think of it as not so much your variable then, but your university or college degree, because these are the kind of things you're going to have to mess with. So, your treasure hunt here, yes, you're looking for a fact that will solve it. But you solve this equation, you solve other types of word problems, you get college credit, and you're a step closer to getting your degree. So step 4, obviously to solve and check for reasonableness. In other words, make sure that your answer is more or less reasonable. You're solving for age of someone and you end up with negative 320 years, you probably made a mistake somewhere. Okay, let's look at an example of steps 1 and 2, and you'll be doing a few of these. Here your directions are to express a given quantity in terms of the indicated variable. Where the indicated variable is the one in step 1 that you're trying to solve for. And in this one we're looking for the sum of three consecutive integers. Right off the bat, I can see some crucial little facts here. N is the first integer. Okay, so this right here, sum, is what we're trying to solve for. N is a little variable we've got that we're going to try to plug back in. Okay, so here's what we're going to do. Our treasure, what we're trying to get at is the sum of the three integers. All right? Crucial fact. They're consecutive, which means in order. Okay, so n is going to be my first. N plus 1, because it's consecutive, you just add 1 to it, you get the other one, is my second. And n plus 2 will be my third. Okay, now we want the sum. All right, well, this is easy. So sum is going to equal to n plus 1, the second one, plus the third one, n plus 2. Or my sum will be equal to 1, 2, 3 n's plus 3. And there's your answer. Okay, one more example here. I want to find 4 consecutive even integers. Whose sum is 428. Okay, and now you can obviously start plugging stuff in. That's considered the best way to do that. Consecutive and even. Okay, on the last one, we didn't have the even part, we just had the consecutive part. Even part means that instead of adding 1, I'm going to add 2, because consecutive even integers will look like 2, 4, 6, 8, and you notice there's 2. And I'm looking for 4 of them. All right, so again, like the last time, S is going to be the sum. All right, this is one of these little intermediate things. Let's do N as my first integer. All right, so N is going to be my first. N plus 2 will be the second, like up here. N plus 4 will be the third. N plus 6 will be the fourth. Okay. So now we come back in. Sum going to equal to n, my first one, plus the second one, n plus 2, plus the third one, n plus 4, plus the fourth one, which is n plus 6. And not only that, I actually know what the value of this sum is. It's 428. I'm going to go ahead and put that in here. So 428 is going to equal to 4n plus 2 plus 4 is 6. 6 is 12. And now I solve for n, which will be my first integer. Subtract my 12, get 416 equals 4n. Divide by 4, n is going to be 104, which will make my 4 integers will be then 104, 106, 108, 110. The fourth step, I'm going to lead up to you. Come back in, check and see, do these add to 428. If they don't, I made a mistake. Tell me about it. If they do, then you just keep right on going. Okay, one more example. These are these riddle type of questions. What we're dealing with here, we've got a movie star that didn't want to give his age to a reporter. So instead, he posed the following riddle. 7 years ago, I was 11 times older than my daughter. Now, I am 4 times as old. How old is the movie star? Okay, so the first thing we need to do then is step 1, we find it. What we're trying to find is the age, I'll call it A, is the age of the star today. All right, we don't know the age of his daughter, so we really have 2 unknowns. Let's go in and say D then is going to be the age of the daughter. Seven years ago. Okay, so the age 7 years ago that he was is going to equal to 11D. All right, now this is the movie star's age 7 years ago. We're looking for what his age is today. So the age today then would be the age he was 7 years ago plus 7 years. So there's one equation. And if we had the age of the daughter at this point, this would be sufficient. But we do not have the age of the daughter, so we have to come up with another set of equations. All right, so what I'm going to do is come back in and say, all right, I've already used this one. Okay? Now what I need to do is come back in and translate this into it. Okay, so the age of the movie star today, okay? Now, and before I do that, I need to make another step. Because what we have is the age of the daughter 7 years ago. So we need the daughter today is going to equal to the daughter 7 years ago plus 7 years. So the age of the movie star today, and the reason we need to do this is we really need to have D, the daughter, the age of the daughter 7 years old. That's what we're trying to, what we're going to have to solve for initially to find the age of the actor. Okay. So the age of the actor today is going to be 4 times the age of his daughter today. We know what the age of the daughter today is. It's D plus 7, so I substituted into here. So it's going to equal to 4 times D plus 7. So now I have 2 equations here. This is really slick. Here's one equation for the age of the actor today, and here's the second equation for the age of the actor today. So all I need to do is set these 2 equal to each other. So I'm going to have 11D plus 7 will equal to 4 times D plus 7. Okay? And then I solve for D, but to do that I'm going to have to clear out my parentheses over here, which means I'm going to have to distribute that 4. So I got 4D plus 28. All right. So I'm going to subtract my 4D over here. That gives me 7D. Then I'm going to subtract my 7. Equals 21. Divide by 7. So the age of the daughter 7 years ago was 3 years. So we can plug it back in either one of these, all right? And I'll go ahead and put it into this one. You can also put it into this one. Either one would work. Now your first check, number 4, is make sure that this number is not negative, all right? Or something really outrageous. So I'm going to have 11 times 3, the age of the actor, plus 7, which is going to equal to 33, plus 7, which equals to 40. Okay, now we're going to draw back in and do a check on reasonableness. 40 years. Does that seem pretty reasonable for a movie star? Probably. It's not unreasonable. And probably at 40, a lot of them would start to worry about actually telling you what their age is. This is how you're going to solve these things.